Hello everyone, my name is Jimmy Daniel. I wanted to appreciate everyone that contributed to my post on LinkedIn. This is a brief demo on how I solved it using MathCAD. My MathCAD sheet is open. And this is the circuit consisting of two resistors and the diode with a voltage source that varies between 5 to 10 volts. And this is the question. I also put all the parameters that is needed. One, this for the diode minimum current is 2 milliamps. And this is the formula for the power distribution of the diode, which is given by maximum current of the diode and the times the voltage drop. Then the voltage drop is 0.7. The maximum power according to the question is 10 milliwatts. Then we go over to the voltage source. They range from 5 to 10 volts, which are specified here. Then I solved for the maximum current using the solve function of MathCAD, which I now got 14.286 mA. I also indicated it here. Now the minimum current, that's the minimum current through the R2. I put it at 0. We have two equations to battle with. The first equation states when the diode current is minimum and when the load current is maximum and the source voltage is minimum. So we specify it here. We say R1 equals to minimum voltage minus voltage drop of the diode divided by plus maximum current. Now the second equation also states when the current of the diode is maximum and when the load current is minimum and when the source voltage is maximum. Is given by the maximum voltage source, which is 10 minus the voltage drop of the diode divided by the maximum current of the diode plus minimum load current, which is 0 as I specified up. Now we equate the equations, the two equations, solving for maximum load current, which is IL max. So when we solved it, we now got this equation. After simplifying the equation, we now got 4.605 mA, which is the maximum load current in R2. So with the formula, I just picked one of those formula. I got the minimum voltage minus voltage drop divided by the minimum current plus maximum current in the load, which is R2. So I got 650.987 ohms. Then for R2, I got the voltage drop divided by the maximum current, which gives me 151.997 ohms. So that is my solution. I'm going to simulate it next using multi-sim from National Instruments. Welcome to the multi-sim environment. As you can see, my circuit is complete with 4 measuring instruments. I have 3 ammeters and 1 voltmeter. I also have an interactive voltage source that varies from 5 to 10 volts. I have my diode. I also have a wattmeter to measure the power dissipation in the diode as I change the values from 5 to 10. Then this ammeter here measures the total current, while each of these other ammeters measure each current in their branches, R2 and diode, while this is the voltmeter. So I run my simulation now. As you can see, at 5 volts, you can see the maximum current coming in, and you can see the diode has 2 milliamps, while the load current is 4.6, which we got from our MathCAD workings. As I vary the voltage, be watching them. You can see it changes. You can see at 8.85 is still within the range. Even at 10 volts, it's still not up to that 10 milliamps. And you can see the power dissipation is 6.78 milliwatts, while this load current remains constant from 5 to 10, and the voltage still is 0.7. So I think with this demonstration, our calculations are correct. But I also included S2. This S2 disconnect the loads from the circuit. So we can see once I click, you can see it goes to the maximum. While if I reduce it, it's the same as the total current coming in. So I put it back. I think that's all for today. Thank you very much for your contribution once again, and I hope to see you in the next challenge.